we are going to look at some operations of functions. So in this first type of problem, they are defining functions in terms of values. So you'll notice they're telling you function f evaluated at -2 is equal to 5, and function g evaluated at -2 is equal to 14. So when you're being asked to find the f plus g of -2, that is the same as you finding the f of -2 plus the g of -2. And so based on what they have defined those as, your f of -2 was 5, plus your g of -2 is 14, so altogether we would get 19. On the second problem, they're asking us to subtract, so again, you can separate them out. This would be the f of -2 minus the g of -2, and if we go back to their defined values, then we would have the 5, this time minus the 14, and we would be left with -9. Multiplication works the same way, so we'd have the f of -2 times the g of -2, which in this case, again with our defined values, would be a 5 times a 14, and so we would end up with a value of 70. 5 times 14. I don't know why that won't right there, but anyway, 5 times 14 would be 70. And then finally, when they have the f divided by the g of -2, so we'd have the f of -2 divided by the g of -2, and in this case 5 divided by 14, and they do not want you to put that as a decimal. Okay, so the next type of operations of functions, they may, instead of giving you values, they may actually give you equations. So notice in this case f of x is defined as the square root of x minus 5. G of x is defined as the cube root of x. So if they're just asking me to add them, again, you can think of it separately. It's just the f of x plus the g of x. So you would take, in this case, the rule for f of x, which is square root of x minus 5, and you would add the rule for g of x, which is the cube root of x. If there are like terms, combine them. If not, you're done. And so in this case, you're actually done. To domain, we think about two things. We think about fractions and we think about square roots. And so in this case, we don't have any fractions, so no worries there on domain, but we do have a square root right here. We don't worry about the cube root right here, but we do worry about the square root. With square roots, whatever is under the square root has to be, in this case, greater than or equal to 0. So it wouldn't be okay to say equal 0 if it were in the bottom of a fraction, but in this case it's not, so we say greater than or equal to 0. Solve that for x. So we have x is greater than or equal to 5. And if we think about the picture of that, we have a solid point at 5 shaded to the right. So we would say our domain starts at 5, includes it, so we put square bracket to include it, and goes to infinity. Okay, step 2 of this problem asked us for division, but they could just as easily do subtraction. They could also do multiplication. So, but in this case, since we're dividing and function f goes on top, then the square root of x minus 5 has to go on top. Function g of x goes on bottom, so my cube root of x is going to go on bottom. Now, when we talk about domain this time, we still have the square root to deal with, and we already found out in the above step that we got x was greater than or equal to 5 because of that. But we also this time have a fraction to deal with. And the issue with a fraction is you can't have 0 on the bottom, so we have to consider that as well. So we have to say this cube root of x cannot equal 0 and make sure that we throw those values out of the domain. So to get rid of the cube root of both sides, we cube. So we're saying x cannot be equal to 0, which if you think about x being greater than or equal to 5, 0 is over here, so that's not part of it anyway, but we at least had to consider it. So our domain is still going to be, in this case, going from 5, including 5, to infinity.